Hi, good evening, everyone. I'm Pooja Venkatesh, and today I'll be talking about managing large-scale AIoT deployments at the edge. I would like to start simply by talking about several problems that exist when deploying AI deployments at scale, and how you define your AIoT stack can help you navigate through these different sets of problems. And then I'll touch briefly into how you can manage the data that's coming from the AIoT software stack. And finally, into designing these device management or edge device management systems, why it is important, what are the key features that will need to be included in these device management platforms. We'll quickly go more in detail into these key features, and finally cover a little bit about Fleet Tracker, which is SmartCow's edge device management platform. So, the biggest problem right now that exists with large-scale AIoT deployments is that the end-to-end deployment itself is so complex, with a hardware part and the software part and the entire pipeline connecting it from end to end. And this is a delicate process, and it also takes a long time for installation, configurations, depending on multiple vendors, etc. That's problem number one. Problem two, there are so many several, interconnected components. Some are related to software, some are related to hardware, some related to firmware, and all of these need to be interconnected seamlessly for the deployment to happen. And the third one is a lot of the, end customers who purchase these edge devices. They typically run some sort of AI algorithms on the edge. These end customers should not need to struggle with the deployment aspect. They should be only focusing on developing their AI models and focusing on deploying their AI models. So deploying the edge device themselves should be seamless. So for all these three problems that exist in the industry itself, there is one thing that can solve, which is the designing an end-to-end AIoT device management platforms. So how is AIoT changing this? Is with Industry 4.0, there has been a transition between collecting the data through different IoT sensors, and then doing some kind of analysis on it, taking an action and putting it back to the edge device. Now, IoT started with this, and we are slowly moving to AIoT, where the data collection itself is so important, because if you see on the left-hand side on the right-hand side of the deck, the IoT circle is mostly a combination of data collection from the sensors, taking an action, processing it, and then putting it back to the edge device, and you collect more data. Where the data is processed is different from where the data is collected, mostly in traditional IoT cases. But with AIoT, the data is also collected at the edge. You process the data, take action also at the edge. So everything is happening at the edge device itself. So to make this part seamless, it is sort of important, highly important, I would say, in designing a proper software stack that enables you to do this data collection and processing all on the edge device. What we do at SmartCow, and what I'm trying to show here, is also this sort of sensor suite that needs to be included in the edge device itself. These sensor suite that collect and generate data include, image sensors, light sensors, temperature sensors, gyroscope, accelerometers, different kinds of gas sensors. The reason this kind of sensor suite is very important is because when you're handling large-scale edge deployments, all of these sensors are collecting data from the field itself, and you can use this sensor data to analyze what is happening at the field and protect your devices from any kind of unprecedented failures. So all the data that's coming from the sensor suite is processed at the edge device itself, and then the action is pushed back and run at the edge device. This part of sensor suite is highly important for edge device management platforms. So let me quickly go into what an edge device management platform itself looks like. So these platforms are something that allows the administrators or end users to provision the devices, manage, maintain, monitor the health of the devices, and perform regular updates to the device, all remotely. So we cannot expect the end users, when they have thousands of devices deployed in the field, to be able to go to the field, to go to each edge device, plug in a USB, and reflash or update any kind of system firmware on it. So the idea of edge device management platforms is to be able to do all of this remotely, and also to be able to enable this kind of deployment to scale seamlessly into multiple other thousands of devices that come in future. So as I said, it starts with, on one side you have these edge devices which run complex AI applications, mostly because they all have sometimes have powerful processing at the edge. And on the server side, you have the device management platform itself that helps you to regularly keep track of how your edge devices are performing and prevent them from failure. So a typical end-to-end workflow looks like what you see on the screen right now. So you have these edge devices that are doing some kind of AI applications, like, I don't know, video analytics applications, like traffic monitoring, retail analytics, anything ranging from healthcare to retail or traffic management. These are running on the edge device. Now, all the metadata from the edge device, including the device health metrics and the device status itself, is sent through different data streamers to a centralized server, where this data is being analyzed and shown to the end user and allow you to push different updates to the edge device. So your device management platform not only sits on the server, a part of it also sits on the edge device itself to be able to communicate between the server and the edge device. So to highlight several aspects of the edge device management platform itself, why it's important, mainly due to 5 different unique features. One, centralized management. You have one management platform to do everything. Second, single click or zero click to minimize the number of actions the end user has to take to perform any kind of operations onto the edge device. Third one is to be able to be easily scalable without hours and hours of configurations and installations. Fourth one is secure communication between the server and the edge device. And finally, 24/7 remote management. So you need to be updated with every metrics that the edge device is actually generating while it is deploying several AI applications. So there are 6 key features that is imperative in any edge management platform. The first one is inventory management. Second is device management. Container management, to manage any kind of AI application containers that are running on the edge. Fourth one, very important, firmware over the air updates. Fifth one, predictive maintenance. And sixth one, issue management. I'll quickly go into each of these key features. So first one is inventory management. Now, so it's important to understand that the goal of designing an end-to-end device management platform like Fleet Tracker is for very large-scale customers where they are buying thousands of edge devices. They're installing it in the field, and it's basically allowing them to manage these fields while deployed at the edge. Now, why inventory management becomes so important is because several of these end users could choose to put some of their edge devices in the field, and some of them could still be in the inventory itself. Now, having an inventory management system built into your edge device management platforms will allow them to validate and keep track of all the devices that are in the factory versus those that are installed on the field itself. So a simple way that can be done is you have all the edge devices. The edge devices can simply be scanned and run a validation script to show what are inside these edge devices, what are they running, and finally you validate the device details and then show it on the edge device platform on how many are in the field and how many are in the warehouse. The second one is sort of the heart of the device management platform itself. And I would like to split it into two parts. The first is the device provisioning. Now, the device provisioning will require 5 important steps. First is to identify and validate all the edge devices. Now, with Fleet Tracker that SmartCow has designed is mostly for NVIDIA Jetson-based devices. So in our case, we first identify and validate all the Jetson devices. 2, because the communication needs to be secure and authenticated, the user should be able to generate individual SSH keys for each of the edge devices. And then they should be able to update host names and create passwords. And 4th one, deploy all the edge devices to the field and then easily add startup commands. Now, this end-to-end 5 steps will ensure that the devices that are being sent to the end customers are properly provisioned. And the moment the devices are provisioned this way, when the end user gets the edge device, they simply need to go to the field, connect it, and all the device metrics start populating into the central device management platform. Under device management itself is the key part of monitoring. So you need to monitor different kind of device health metrics like device temperature, CPU utilization, GPU utilization, fan speed, eMMC, how much of it is being used, NVMe, how much of it is being used, and at the same time, if the edge devices are using certain hardware accelerators or libraries, you should also be able to provide information to the end user on how well these hardware accelerators are being used, whether some of these libraries are being used or not. So under monitoring, there are sort of 5 key elements that the end user will require. First is the device metrics, as we saw before, the alerts, CPU usage, GPU usage, anything regarding the edge device itself. And second is on the storage details, how much of eMMC or NVMe or any kind of SSDs that are included in the hardware device. 4th one is the process status, which is the hardware accelerators and libraries that are in the edge device. And the next one is container management. Because the end customers are running certain AI applications, they're usually containerizing this and running it on the edge device. So container management basically allows the end user to view all the containers that are running on the edge device and also allow to push different containers or update or restart existing containers on the edge device. And finally, for large organizations who have different teams like site engineers, operations, technical teams, software engineering teams, etc., it's very important to have an end-to-end ticket or issue management lifecycle included in the device management platform itself. So the management and maintenance part of designing an edge device management platform is very important, and at the same time, it's very important to make it highly available, because all these edge devices are clustered and deployed over thousands of kilometers in the field. It's important to ensure that on the server side, where your edge device management platform sits, it's highly available and it can easily fall back to different nodes. So in this case, there are 6 important things that you need to take care of. First is ensuring there are multiple fallback nodes available. If one of the nodes fail at any point of time where your device management platform resides, it should be able to automatically fall back to a different node. Second is allowing end users to use some web-based repositories that allow them to easily manage different AI containers. Third one is mostly from an advanced database management system, because there are a lot of data exchange happening between the edge device and the server, because of all the device metrics that are being sent to the edge device every 5 seconds. You can configure it to be sent every 10 seconds, every minute, for example. So there is tons of data coming into the server itself. So an advanced database management system is imperative to be followed. The fourth one is data flow. It's important to provide the end customer an ability to dynamically add or remove different data stream pipelines. This way, when at some point they feel some information is not needed for them, they should be easily allowed to exclude that or remove that data pipeline from reaching the servers itself, so that they're not bombarded by information. The fifth one is, of course, access control, because each of the end users have a whole team of people managing different sets. So they should be given an opportunity to create different users and access. And finally, security, most important of all, because there is a lot of end-to-end communication between the edge device and the servers. You need to make sure that this end-to-end communication is highly secure and no one can break into these systems. A typical edge device management architecture looks like this. So you have these edge devices that are in the field, mostly NVIDIA-based Jetson devices, at least for fleet tracker. These edge devices typically run AI models. As I mentioned, this belongs to the end users themselves. And then there are some native applications that need to be installed on the edge device, because since the edge device management system needs to communicate to the edge device itself, there needs to be some daemons running on the edge device that requests to pull this information. So you will have certain native applications running on the edge device. On the server side, you have message brokers, authentication tools, database management systems, Docker registry for the end user to use, and your device management platform itself. And then for the host servers, in the host servers, you have the firmware that is sitting at the host servers. So whenever there is always a communication between the client servers and the edge devices, and only when there is a requirement for the edge device to run some sort of firmware update, it can directly connect to the host servers, pull the firmware, just like how it happens with your phones. Now, there are specific places where the end user has their own private network, and the edge devices cannot connect to the host servers. In this case, there are specialized ways where you can allow them to move the firmware package into their client servers and then push it to the edge devices. We'll quickly move into what constitutes this whole data streamer itself. Now, it's important to have a lightweight metric shipper inside the edge devices. And these are basically data shipper that is lightweight. One, it has to be extensible to integrate with different C++ pipelines, inputs, filters, etc. This data shipper is what is like at the heart of the edge management platform itself, because this is what collects all the edge metrics and then ships them to the edge device. At the same time, there needs to be some sort of intelligence on the edge device so that the end user is not bombarded by alerts. For example, if they're running some sort of AI algorithms, people who have worked with AI algorithms know that at some point the GPU utilization suddenly peaks or CPU utilization suddenly drops for some reason. These kind of anomalies, as we call it, shouldn't be shown as an alert to the end user because it lasts only for a few seconds. So the metric shipper should also be equipped with some kind of ML algorithms that filter these anomalies and only send the most important alerts to the end user. So this is just a brief of the required functionalities that the metric shipper needs to have. And additional features like swap usage, gyroscope, magnetometer readings, the BSP statuses, etc. will help to improve your device management platforms. Let's quickly move into the cloud-based container management system. Now, under container management, I would like to split it into two parts. One is updating the end users containers that are sitting on the edge device. So these could be AI applications or any kind of containerized applications that the end user has that's running on the edge device. Now, because each of these containers need to be restarted at time to time, for example, imagine this scenario where the customer is running, say, some kind of traffic monitoring application on the edge device. Tomorrow he decides that on this particular edge device, I don't want to run traffic monitoring. I want to run something else, maybe people management solutions, for example. So they should be able to remotely update their container or stop the existing container, push a new container on the edge device and start to run. So the edge device management platform should be equipped to do this seamlessly with a single click and not using a lot of bandwidth to pull in the containers, push them onto the edge device and run them. The second part is SSH key management. Because of this data exchange, it is imperative that the data exchange is secure and they should be able to do it seamlessly. And finally, it needs to be flexible so that the end user should be able to easily integrate this part into their own CI/CD pipelines. Typically, it's required to also have a schedule manager where the end user can easily schedule different container updates basically they can select a group of edge devices, select a schedule and push container updates during this schedule. The next important part is firmware over the air updates, and this is sort of the most important feature of any AIoT device management platform. Because in large scale deployments, the devices are expected to run 24/7, not being, monitored continuously. They need to be able to run 24/7. And to make this happen, sometimes it requires for the end user to push security updates, for the host to push any firmware updates, etc. So it's important for the end user to create a group of devices or schedule firmware updates to a group of devices and allow to do this remotely, with a single click. Now, doing firmware updates is one part. The second most important part is also offering OOB functionality or out-of-band functionality, where the end user should also be allowed to back up their firmware and recover it when something happens to the edge device. And to be able to do this, they should not have to go to the edge device, plug in a USB key and run all these edge devices, run this OOB or firmware over the air updates. They should be able to do this remotely as well. The last part is the predictive maintenance part. So as I mentioned previously, it's important the end user is not bombarded by different sets of alerts. So the alerts need to be filtered with certain ML algorithms. It's also helpful when you run certain kinds of predictive maintenance tools, like predicting time to failure, where you can alert the end user and say that, your device is about to fail, so you need to quickly go to the device and fix it, or run certain updates to fix the device and avoid it from failing. The last part is, again, as I mentioned, for large-scale institutions where you have a whole ticket management lifecycle, where they can create different issues, allot them to different teams, etc. So to summarize, all these key features are highly important to design an effective device management platform, and they all need to be put into this unified dashboard where everything is easily managed and the end user is not bombarded by unwanted information, and everything can be done seamlessly through single click. To quickly summarize, this is what we are doing with Fleet Tracker. Fleet Tracker is SmartCow's edge device management platform, specifically designed to run on NVIDIA-based Jetson devices manufactured by SmartCow. With this, you can easily manage devices. You can easily scale devices by allowing the key features that we have seen before, the 6 key features. You can also update these devices with a single click and manage your deployments at ease. So if you need to know more about Fleet Tracker or how to design better device management platforms and how it could help seamlessly integrate into large-scale deployments, you could contact us, or you could drop by our booth in Hall 2330 when you have, and we'll be happy to help you with your questions or take in your suggestions to improve these edge device management platforms. I hope this was informative. Thank you very much.